Alright, so today I want to talk a little bit more about the unit circle, but dealing with reciprocal identities, so not just sine, cosine, and tangent, but what about their reciprocals, which would be where we flip the fraction. So cosecant goes with sine, cosine goes with secant, and tangent goes with cotangent. Now I think it's pretty easy to remember that tangent goes with cotangent in terms of being reciprocal. So what I mean is, if tangent is 3/4, then the cotangent would just be the flip or the reciprocal of that, which would be 4/3. So for example, if we find something that was like 1/2, the reciprocal of 1/2 would be 2/1. And so once you find sine, cosine, and tangent, you've done most of the work. Really just flipping that fraction would give you the cosecant, secant, cotangent. Now, some people are always like, why does the S in sine go with the C in cosecant? And cosine goes with the S in secant. Shouldn't cosine go with cosecant and sine go with secant? I wasn't there like 2,000 years ago when they figured this out. So yes, you do need to remember that sine is a reciprocal of cosecant and vice versa, cosine and secant, and then tangent and cotangent. So we're going to do 3 examples real fast to make this video fairly short. Now, if I want to find the cosecant of 210, we need to remember, okay, cosecant is sine. It's sine's reciprocal. So let's first, maybe in our minds until we get used to this, find the sine of 210 just for right now. And so as I look at my unit circle, and I'm going to go around and look at my angle measures in degrees, here is 210 degrees. Now, cosecant's reciprocal is sine. The sine, remember, sine is our y value. So the y value at 210 degrees is -1/2. Now, if I wanted the cosecant or its reciprocal, we're not flipping the sign stays negative. So if the sine value is -1/2, the cosecant is still negative, but instead of 1/2, this would be the reciprocal, which is 2/1, and we can just write 2/1 as 2. So if sine of 210 degrees is a -1/2, then its reciprocal, called cosecant, would be a -2 or 2/1. In the same way, secant, now dealing with radians. Looking at my radian measures, I have pi/6. So over here, here's pi/6, and I want to figure out what is secant. Now, at first, cosine goes with secant, and so my cosine value, which is my x value, so what is the x value of pi/6? Well, my x value of pi/6 is going to be radical 3/2. But I don't want radical 3/2. I want its reciprocal, called the secant, which would be 2/radical 3. Now, some people would like you to rationalize the denominator, meaning you'd have to multiply top and bottom by radical 3/radical 3. And if you did that, another way this could look would be 2/radical 3/3. We're going to talk about this more in class. I think most AP tests and books allow you to leave it like this. So we're going to leave it like this for now. And we'll practice that a little bit more in class. Now what about cotangent? So cotangent of 2 pi. So remember, 0 and 2 pi have their ending point, their terminal side at the same spot. So cotangent of 2 pi. Well, I want to know what the tangent of 2 pi is first, because that's our reciprocal. So okay, let's think about this. Tangent is y/x, meaning tangent is going to be your 0/1. Well, what's the reciprocal of 0/1? Well, that would just be 1/0. Now, here's where I want you to be careful. If we were asking for the tangent of 2 pi, it would be 0/1. What's 0 divided by anything? It would be 0. So we sometimes forget that 0 is a number. And if you ever forget, you can use your calculator. 0 divided by 1, and it would tell you 0. Now what about the reciprocal though? So the cotangent of 2 pi is now, instead of y/x, it's x/y, the reciprocal. So in this case, it'd be 1/0. Now, can you divide by 0? And the answer is no. Why? Because it is undefined. So in your calculator, if you put 1 divided by 0, you would get an error message. And that error message is your indicator that this is actually undefined. Sometimes we put a 0 with a line through it, or we can just write undefined. So we will practice more with the unit circle and the reciprocal identities